Imagine being on a big wooden ship, far out at sea. There are no roads, no signs, just endless rolling water in every direction. The captain knows how far north or south he is, but he has no idea how far east or west he has sailed. He is sailing completely blind. This wasn't a small problem. For hundreds of years, this was the single biggest danger for every sailor. Ships full of treasure, and more importantly people, would crash into rocks they couldn't see coming. Or they would get lost in the middle of the ocean, running out of food and water. It was a terrifying mystery. So, what was the secret to finding your way? It was all about time. To know where you are on the giant spinning Earth, you need to know 2 times at once. You need the time on your ship, which you can find by looking at the sun. And you need the time at a place you know, like your home port in London. Think of it like this. If the sun is highest in the sky for you at noon, but your clock says it's 2 o'clock in the afternoon back in London, you know you are 2 hours away. That time difference tells you exactly how far east or west you've traveled. The Earth spins at a steady speed, so time equals distance. The problem was, no one could build a clock that worked on a ship. Clocks back then were big, swinging pendulums. The rocking of a ship, the salty air, and the changing weather would make them stop working or tell the wrong time. A clock that was off by just a few minutes could mean being lost by many, many miles. The smartest people in the world tried to solve this. Most of them were astronomers, people who study the stars. They had a very clever but very difficult idea. They wanted to use the moon and stars as a giant clock in the sky. By measuring the moon's position against the stars, they could figure out the time. This was called the lunar distance method. It was a beautiful idea on paper, but it needed perfectly clear skies, super complicated math, and a very steady hand on a rocking ship. It was an idea from a quiet room, not a stormy sea. But there was another idea, one that most people thought was impossible. Just build a perfect clock. So who would solve this incredible challenge? A famous professor from a big university? The king's best astronomer? No. The person who solved the greatest scientific puzzle of the 18th century was a carpenter from a tiny village. His name was John Harrison. He had almost no formal schooling. He didn't learn from fancy books or famous teachers. He learned by building things with his hands. And this made all the difference. He wasn't just smart. He was a new kind of genius. Even as a young man, John Harrison was building clocks that were better than anyone else's. He made them almost entirely out of wood. He didn't do this just because it was cheap. He discovered a special type of wood that was oily, so his clocks never needed cleaning or oiling to keep running smoothly. This was a brilliant new idea. So John Harrison started to build. He spent 5 long years in his workshop, not just thinking, but making. This carpenter was creating a machine to challenge the stars themselves. He believed a perfect clock was possible. It was a very brave idea. His goal was to build a timekeeper that didn't care about storms. It had to ignore the wild rocking of a ship. It needed to work perfectly through changing heat and cold. This wasn't just about making a clock, it was about taming time itself on the open ocean. His first sea clock was called H1. It was a beast. A 75-pound machine made of shining brass and powerful springs. It was huge and complicated, but it was also beautiful, a work of mechanical art built to solve an impossible problem. The most clever part of H1 was how it handled the rocking of a ship. A normal clock uses a pendulum, a weight that swings back and forth. But a pendulum would be useless at sea. So Harrison invented something new. He used 2 huge balance beams linked together that swung in opposite directions. When the ship rocked one way, the beams would swing to cancel it out. It was genius. But this incredible machine was just the beginning. This was not a story with one single aha moment. It was a story of hard work that lasted for decades. After testing H1, Harrison spent years building his second clock, H2, and then a third, H3. Each new clock was a chance to make things better. He was on a long journey of tinkering and perfecting his ideas. He would discover a small problem, like a tiny bit of friction, and invent a whole new part to fix it. He was teaching himself how to build the perfect machine, one gear at a time. And then, after building these giant, heavy clocks, Harrison had a revolutionary idea. It was a huge twist that no one saw coming. He had spent his life building bigger and stronger machines to fight the sea. Now, he would try the opposite. He realized the solution might not be a giant, complicated clock at all. What if the answer was a watch? Something small enough to hold in the palm of your hand. It was a shocking thought. After all that work, he was ready to start over with a tiny device. This was the big breakthrough. A smaller machine with a faster beating balance wheel could actually be more stable. Its quick movements would be less affected by the slow, heavy rocking of a ship. It was a complete change in thinking, from fighting the ocean with size to avoiding its power with speed and smart design. To make it work, he had to solve the problem of temperature. On a long sea voyage, the weather changes from hot to cold. This makes the metal parts of a clock expand and shrink, which changes the speed of timekeeping. So Harrison invented something amazing called a bimetallic strip. It was a tiny piece made of brass and steel fused together. As it got warmer, the strip would bend just the right amount to keep the clock ticking perfectly. It was automatic temperature control, invented in the 1700s. The genius of H4 was its small size and amazing new parts. It had special metals that didn't change with heat or cold. It had tiny bearings that moved with almost no rubbing. This wasn't just a clock, it was a perfect time machine, ready for its biggest test. Now came the real challenge. H4 was taken on a long sea voyage to Jamaica. For 81 days, the ship rocked and rolled through storms. The weather changed from freezing cold to boiling hot, and through it all, Harrison's little clock kept ticking perfectly. It lost only 5 seconds. He had done it. John Harrison had solved the longitude problem, but the Board of Longitude, the group with the prize money, was not happy. They were powerful astronomers. They believed the answer was hidden in the moon and stars, not inside a box made by a carpenter. They refused to pay him. This is where the story gets even bigger. It's not just about a clock anymore. It's a story about two different kinds of genius. The big discovery here is that there is more than one way to be smart. The astronomers had a genius for big ideas. They saw the universe through math. They were very smart with books and theories. John Harrison had a different genius. His was a hands-on genius. He understood how metal bends and how gears turn. He learned by trying and failing and trying again. For years, Harrison fought the board. They made him build more clocks. They kept changing the rules. He grew old and frustrated, but he did not give up. He decided to go to the very top. He would ask the king for help. Harrison, an old man now, met with King George III. He explained his long, hard journey and showed how his invention worked. The king was amazed by his work and his strength. He famously declared, "By God, Harrison, I will see you righted." With the king's support, the government finally gave him his prize. John Harrison's victory was a win for every person who thinks differently. His amazing invention made the seas safe. It allowed ships to explore new parts of the world. It connected people like never before. His hard work saved countless lives. His idea is still with us today. In fact, it's probably in your pocket. Every time you use GPS on a phone, it uses the same basic idea. Super accurate clocks, just like Harrison's, tell you exactly where you are. His legacy is everywhere. The story of the self-taught clockmaker is a powerful lesson. It teaches us that a great idea can come from anyone. It shows that genius isn't just about what you know, it's about what you are willing to do to find the answer. John Harrison's incredible story doesn't end with a prize. It marks a big change in how we think about genius itself. His victory was not just for him, it was a victory for every person who solves problems with their hands. He showed that a workshop can be just as important as a university library. This was the genius of a maker. The astronomers looked up at the stars for answers. They used big math and complex charts. But Harrison looked down at his workbench. He found truth in the way a gear turned or a spring pushed back. He was a carpenter who thought with wood and metal. This was a new kind of scientific hero for the 18th century. Let's look at one of his amazing ideas. It is called the bimetallic strip. Think of two different types of metal, like a strip of brass and a strip of steel, fused together. When it gets warmer, brass grows a little more than steel. When it gets colder, it shrinks a little more. A simple idea, but it was revolutionary. Because the two metals were stuck together, this difference in size made the strip bend. As the temperature on the ship changed, the strip would curve one way or the other. Harrison used this gentle, predictable bend to automatically adjust the clock's balance spring. It canceled out the effects of heat and cold. It was a self-correcting machine, a work of pure genius. This was more than just clever clockmaking. This was a new way of proving an idea. Instead of writing a paper, Harrison built an argument. His proof was a machine that worked perfectly, even in a storm. He solved a huge scientific challenge with gears and springs, not just with numbers on a page. His workshop was his laboratory. Every piece of polished metal was a test. Every new design was a question he was asking the universe, and the ticking of his clocks was the answer coming back to him. This was the heart of his method. He would try and fail and learn and try again for decades. Think about how we learn best. We don't just read about things. We build them. We try them out. We see what happens with our own eyes. This hands-on way of learning was what made John Harrison so special. He was a master of trying, testing, and tinkering his way to the truth. This is a powerful lesson from his journey. Every setback was a discovery. Each time a clock ran too fast or too slow, it wasn't a failure. It was a clue that pointed him toward a better design. He used his mistakes to build something that had never existed before. He was a carpenter who simply refused to give up. So the story of how longitude was solved is about more than just finding a location on a map. It's about finding a new way to be smart. Harrison's life shows that true understanding comes from doing. It comes from the patience to build something, test it, and make it better, day after day. And that is his greatest legacy. John Harrison, the self-taught clockmaker, proved that the world's hardest problems can be solved by anyone with a curious mind and determined hands. He showed us that genius doesn't need a formal education. It just needs a chance to build something incredible.